Hello, my name is Brendan Enrick, and I'd like to welcome you to DevChatter Basics. In this episode, we're discussing LINQ in C#. We'll be going through some of the ways that we can use LINQ in C# to change the way we write our code. Whether you've been using the language for years or you're just starting with it, a good foundation of the basics can help improve your coding skills. Get comfortable as we learn about LINQ. When C# developers talk about LINQ, it would make sense if we all meant language integrated query, as that's where the name came from. It's usually not what we're talking about, though. The code we're seeing here is using what's called the query syntax of LINQ. It's the actual integrated querying in the language. You might find this somewhere, so I'll talk about it a bit at the end of the video. For now, though, we're going to focus on the extension method syntax of LINQ in C#. And if you haven't seen how extension methods work or how to build them, go ahead and check out our previous DevChatter Basics video on extension methods. This is the method syntax doing the same thing as the previous query we were viewing. We call it the method syntax because it has the same functionality as the LINQ query syntax, but instead uses these chained methods that are included in the system.link namespace. Let's have a look at what's going on here. First, we created an array of integers and stored them in a variable, number, with the type int array. Next, we declare a more complex type, an IEnumerable of integers, and into it, we assign the rest of our LINQ methods. We take the numbers array, the where will filter down the numbers to only those less than 10, and then we order them by the number itself, and we put it in ascending order. If we wanted the result to still be an array, we could add another method to the end of the chain. And we'd end up doing this code instead, returning an array of integers. The plan for this episode is to do some hands-on explanation as we code. So let's jump in, and I'll explain how each of these works. Here we are in Visual Studio Code, and I've started up a basic console application, and we haven't really done anything with it yet. All it is a standard hello world, so let's go ahead and run it just to confirm that it does run. So we'll do a .NET run, and this is going to print back hello world. So we want to take a look at LINQ. In order to do this, the best example that we can do for starting out is to get ourselves a collection. So let's make a collection. We'll start off by making it an array. We'll call this numbers, and our numbers array will be a new array, and in that array we are going to put in some numbers. So this is our starting array, and we can do some nice little things with it. If we take these numbers and we only want to get the odd numbers, for example, we could write numbers.where. Now when I do this, something happens. If we look up here using system, but if I go control dot, I can add a using system.link, and I mentioned earlier that if you are interested in learning more about extension methods, you should take a look at our DevChatter Basics video on extension methods. This is an extension method that is part of the system.link namespace. So when we use where, you can see that where takes an argument that is going to be a function that receives an integer and returns back a Boolean. And this function's called predicate, but that's really saying essentially, predicate in this case, just think of that as saying filter. So a where has a filter, and this is the function that helps us filter. It helps us determine for any given integer, should we keep it or should we remove it? And that's what the Boolean means. If we should keep it, we return true. If we should remove it from the set, we say false. Now I want to clarify, this does not remove them from the int array that we started with. So the numbers array will always have that set, but we're going to remove some of them from our result. So let's go ahead and say int array filtered numbers equals this. And if I say .toArray, on the end, then we'll end up with an array. So let's write that filter predicate. So we'll say if x %2 equals 0, this will return back any number that when divided by 2 has no remainder. So that means get any of the even numbers. Now, if you're not familiar with lambda expressions, we will be doing a DevChatter Basics video on lambda expressions as well to explain how these work. But the quick answer is, this is the parameter of a function, and this is going to be our integer we specified when we described the function. This says, hey, the right-hand side is going to be the actual expression that is the function, and this is the return value. So we're returning x %2 equals 0. Okay, let's go ahead and print these out. And when we run this, we can go ahead and .NET run, and we'll get back 2, 4, 6, 8. If we were to change this, and we said instead does not equal 0, so that means where the division would be having a remainder, that means we're going to get the odd numbers. And if we run this, we get 1, 3, 5, 7, and 9. So this filter is really just determining which numbers should be kept in this new collection. And that's how where works. Let's go ahead and take a look at how ordering works. So this set of numbers I wrote in here is in order, but if we were instead to say, and we'll even throw in some repeats. So there's a set of numbers, and again, if we run this, we get back 5, 7, 3, and 1, and if we switch this to show the even numbers, we get back this set. Notice in both of these cases, the collections were not in order. With LINQ, we can go ahead and do an order by. We can just say order by the value itself. When you're ordering by a more complex type, you need to specify what property of it you want to order by. So, for example, if you had a collection of people, you might order by their last name. Or if you have a collection of products, someone might want to order by price or by their review rating. When we run this code, we should now see the numbers in ascending order. And the same thing goes if we look at the odd numbers. So there's the odd numbers in order. Okay, let's take a look at order by descending. You can probably guess that order by descending does the reverse of what we just did. I'm not going to run through all of them, but you'll notice that it went from 1357 to 7531. Okay, so that is order by. This was where. And then we did a to array. Now, it's fairly common for people to write these in this way because you can kind of see the steps. We had numbers. We said, okay, numbers where it was an odd number, and order by is that. And then we have our to array, which tells it to store it in an array. Now we could leave this as an IEnumerable. It doesn't have to store it as an array because the result, if we look at this, is an I-ordered enumerable. The result of this one is an IEnumerable. So we do have those types, but a lot of people like working with arrays, so we did that. And it's a small set, so it works fine. Next, we can do a couple of other things. We could skip the first one every time. And this will actually tell it to leave off the first number. So if we run this, instead of 7531, we should just get 531. And there you go. So skip lets us do that. And now, in addition, we could just say to take 2. Maybe we only want to get the second and third number, but nothing more. And then we just get 5 and 3. So skip and take allow us to decide how many we want. And for anyone that's wondering right now, what happens if I do go beyond the array? you'll notice that it just continues taking until it reaches the limit and returns back whatever it found. So if you want to take them all, leave off take, but if you want to limit it, just say, hey, I only want to take 10. Now keep in mind that your result might not include 10, but you didn't want any more than that. Let's remove the skip and the take. You can also use a take while, and this does a predicate. So we could do the same thing we did before and say take while x is greater than 3. So this would return back only the items that are odd numbers that are greater than 3. And since we ordered, that means as soon as we hit a 3, we'll bail out. If we were not ordered, keep in mind that this would cause us to bail out as soon as we found that one. So this returned back 7 and 5. LINQ has a whole bunch of helpful little methods to let us do all of these kinds of things. Let's take a look at the next most important thing. That's going to be the select extension method. In order to show the select extension method, it's best to use a complex object. So let's start by creating a new type. So we've created a new type called person, and on that person we have name and age. So let's make our collection be names and ages instead of being integers. Once created, we need to make sure that we give each one of these the properties that they should start with. So now we've got some fake data created that has some unique people, but we've also got repeat names, last names, we've got some ages with some similarity, so a reasonable amount of data to work with inside of a collection. Let's get rid of our where. Let's rename this from numbers to people. We'll get rid of this, and order by descending like this is not going to work because we can't just sort by person. So this says sort by the person. Let's instead try sorting them a little differently. Let's sort them by age, for example. So in order to do that, we specify what property on our person object. Remember, inside of these LINQ expressions, we receive one instance of each object inside of our lambda expression here and choose what property on it we want to access. So we're saying order by the age, and this is going to be descending, so it means this will be the first record, and then this one, and this one, and so on. So let's write these out as well. I mentioned that the important feature that we needed to talk about, the new extension that we needed to discuss, is called select. So let's go ahead and use it here. So we'll say select, and again we're going to do another lambda expression, and we're going to say name. So essentially what this says is take all the people in our person array, specifically our one that we have ordered, and select their name. So in this case, what that means is take that value and make that be the only one in a new collection. So this will return back an enumerable, we'll consider that to be a collection in this circumstance, that is just the names. So let's go ahead and run this and see what happens. And there we go. It printed out the names of the people in order. Now, that's kinda useful, but it obviously didn't print it out really the way we wanted it because we probably want to show some information because we can see that's the order, but we can't see their ages. So let's go ahead and put that in there as well. So I said that this was selecting the name, but inside of a select, we can actually do whatever we want. So let's illustrate that by making this a little bit clearer. So instead of having this here, let's go ahead and extract out a local variable. And this illustrates an amazing point right here. So when I've extracted this, you can see that the return value of the select is actually an IEnumerable of string. Let's get rid of the namespace just to make it a little bit clearer. So we end up with an IEnumerable of string. We'll tell VS Code to add that using statement at the top. So this was the prefix namespace that was there before. And then we have IEnumerable of string. Now, we had talked about that, and I said that we could just to-array this. Now, this is not an efficient way of doing this because I have to listed twice. So we don't have to do this part here. We can instead put this same select that we did here into this one, and now that collection, instead of being an array of people, it will be an array of string because we're selecting the name property off of it. And the name property is a string. So we have essentially changed what type this collection is by using the select. Let's go ahead and take this value and put it in here again. And now when we run this, we should get the exact same result, but now when I show how to do this, it should be a little clearer what's going on. I'm going to write this as string interpolation. If you haven't seen this in C#, this essentially is a string, and we're going to put variables inside the string, so it's going to create it. So this is a string, which we're going to put the full name in, and then after that, we're going to add in another property from that object. So we're going to add in the name and the age. And now you can probably guess what this is going to do, but this is actually now going to give us a collection that includes both the name and the age of each one of these people, and that works really nicely. The LINQ statement that we've got here has a couple of parts to it. It says, take all the people, order them by their age, and then turn it into a string. Now, remember that these had to happen in this order, because if I go this way, we take the people, we turn it into a string, and there no longer is an age property because the return value of the select is an IEnumerable of string. So that means we can no longer order by age because there is no age property because string doesn't have one. See how the X here is a string now? So the order does matter on these, and it will determine how those pieces run. So we've said take the people, order, and extract it out into a structure. So essentially take those parts and put them the way that we want it. Now, these can be used for other means as well. It doesn't just have to convert it into a string. You can actually use selects to create more complex objects. So, for example, if I had an array of strings that were all like written out date times, I could, inside of a select statement, parse all of those into a date time object, and I would end up with a collection of date times. So essentially, LINQ is just giving us ways of manipulating data, and that's what makes it so powerful inside of C#, is we have a lot of ways of manipulating data that don't require that we create lots of loops and lots of other structures. So it's really nice for that. Let's go ahead and run this just to make sure we didn't break anything, because we were moving things around, and works like a charm. So we have ordered by age. I don't want to do that anymore. We're going to show a new thing. So instead of ordering by age, I want to do a group by. Now, this is a more complex part of LINQ, so we're diving in a little bit further when we talk about group by. Group by's responsibility is to take a collection of data and group it based on some similar attribute that the items in the collection will have. That, in this case, is going to be the age. I want to get how many, what decade they are in. So people in their teens, 20s, 30s, and we're going to group by that. So we're going to say group by, and every time we use one of these LINQ statements, it's always going to take a lambda expression, they pretty much all are, and it's going to give us an individual item in the collection. So this is going to be a person object. And from that, we're going to say x.age, and we're going to say divided by 10. Now, if you remember your integer math, you'll know that when I divide by 10, we're going to lose the remainder. So 18 divided by 10 is going to be 1, 28 divided by 10 is going to be 2, and 38 divided by 10 will be 3. So we just lose off the remainder, and that's going to group us by decade. When we do that, we get back a different object. Notice that in this select, I'm getting little squiggly underlines here. Let's go ahead and select a little bit differently. People in their x.key. Now in this case, this value that we created here, this is the key, because that's what we have grouped by. So we have grouped by this value. So this is going to be their key, and we're going to say times 10. So it'll say their 10s, their 20s, their 30s. We could obviously translate this into words like teens, 20s, 30s, but that's beyond the scope of this. And we're going to say a number. Let's put it inside of these parentheses. Why don't we say x.count? And this will give us the count of the people that are in that set. So people in their 10s, there are 2. People in their 20s, there's 1. And people in their 30s, there are 2. So we're able to take this data, group it based on a calculated value, and get back the result. So that's pretty darn powerful. That's some amazing stuff that LINQ is getting us here. Let's take this one step further. So we said people in their 10s and we said the number. We printed out the count. But I don't want to do that. I want to actually show them. So let's do this. Let's, instead of saying count, let's say select. So we're going to actually now select their name into this. Now this isn't going to be perfect because this is still not an actual value here. So I want to get a little bit better with this. So let's go ahead and string join them as well. So let's do string.join, just like we did below. It's the exact same thing. And just to make this a little clearer, I'm going to get myself a new line. So we're going to say string join, and we're going to pass in that select. So this code should go ahead and put those in there. So now it says people in their 10s, there's Brendan Enrick and Brendan Smith, people in their 20s, Michael, and then people in their 30s. And it lists out very nicely in that structure. Now obviously we're not writing console applications that print out names and strings, but hopefully you can see the power of manipulation that we can get through selecting objects and working with group bys. So when you think of this, just remember, after you've done a group by, you're now working with a grouping. So it is the key, and remember that X itself also contains all the items. So notice I was able to select that grouping to get individual items. So you have the items and you also have the key that you use to group them. That's all a grouping is. It does seem complicated and it is a difficult concept to understand, but hopefully this helps you to grasp that concept. So group bys, really, really powerful. There are a number of other LINQ concepts that we could dig into. There are select manys. Let's just take a look at a few of them. So there are the accepts, there's distinct, there are, we already did the group by, for example. You can check the last item, you can check the first item, you can check a single, you can do all kinds of things with LINQ to get this data and manipulate it. But I don't want to show you all of those because that will take too long and is a little bit complicated. So let's show a couple of other things and we'll take a look at that. First off, let's just cover really quickly. So we'll do linkedpeople.last. So that should get us our last item. This should get us our first item, because you should know what those are. And then I'm going to have this program, so we're going to run it, but then I'm going to make it throw an exception in a minute. So first off, we're going to run this. So it printed out the whole thing here, and then it printed out the first item and then the last item. So again, remember, our linked people is an array of strings, so that's why we're printing out that whole string. Now, if I want to make it throw an exception, I can do single. And when I do single, it is actually going to throw an exception because there's not just one. Now, I'm also going to show you one more gotcha. So if we do first or default, that will work fine. So the or defaults, when you see that, what that stands for is grab the first one, or if there are none, go ahead and give me the default value for that item. So in this case, a person object, the default value is null in this program. So we're going to receive back a null object, and that's fine. Now, obviously we had items in the collection, so it didn't return back null. But the same would go for last or default. Again, if there were 0 items in the collection, it would return back null. The exception, the one that usually gets people, though, is single or default. And when you use this one, it still throws the exception. And the reason why is because the single or default throws an exception if there's ever more than one, whereas the other two work fine if there's more than one. So if you know that there's only supposed to ever be one, you want to put in single instead of first, because single will throw an exception and alert you, the developer, to the fact that there is something wrong with the code. And that's one of the useful features and potential gotchas in LINQ. We'll save looking at further parts of LINQ for a future episode of DevChatter Basics. Thanks for learning about LINQ with us. Join our live streams on Twitch at twitch.tv/devchatter. If you enjoyed this video, be sure to click the like button and subscribe to DevChatter to catch all of our future episodes. Happy coding!